Oh hi! Greetings everyone. Today, me Nikhilesh Duggal. I am going to show my chemistry lab. All these years I have worked hard to create these chemicals. Now I am going to read a description. Actually, I have recited a description on these chemicals and I am going to tell about these chemicals. First, we start off with the hydrochloric acid. Hydrochloric acid is used in bleaching industry because it has a high chlorine content. Since it has a molecule of hydrogen bonded with another chlorine atom, still the power of hydrochloric acid is enough to bleach water, to bleach chemicals, and it is also used in water purification. Hydrochloric acid can be also used to create other acids by mixing them with their respective salts such as metal sulfates and metal nitrates mixed with hydrochloric acid create respectively sulfuric acid and nitric acid. Then we move on to aluminium trichloride. It's also known as aluminum chloride, having the formula AlCl3. The aluminium chloride is a chemical compound made from hydrochloric acid. It can be created by reacting solid aluminium metal by hydrochloric acid. Aluminium chloride is actually also used in explosives and it is used in some chemical reactions because it can be used to create metal trichlorides. Aluminium trichloride is also used as various purposes for creating hydrochloric acid. Actually, each chloride salt has a special quality that it can create hydrochloric acid by reacting in the presence of other acids. Now we move on to this chemical compound. It's copper chloride. Normally, copper doesn't react with hydrochloric acid because it's a very stable metal having a valency of +2. Its symbol is Cu, atomic number 27, and it's a very stable element. Copper chloride has a symbol of CuCl2. It is made by reacting copper with hydrogen peroxide and hydrochloric acid. Copper chloride is actually very bitter, and hence it cannot be used in tasting substances. And copper chloride actually doesn't have many uses, but its a very special use is that in liquid solution it is used to make copper circuit boards. Here I have one example. I'm going to show you this one. This circuit board, as you can see, has a green plating of some chemical. I'm going to scratch it for you and then I'm going to show you. As you can see, this green powder is coming off. This powder is copper chloride.
Please show us, doctor. Sorry, scientist.
Actually, this powder which I scratched off the surface of this copper circuit board is copper dichloride, because copper chloride has a very good electrolyte, because it can transfer the copper's ions very easily to other parts of a circuit. It helps to transport electricity as well. And now we have fluorescein. It's a very special dye. It has UV radiation fluorescence, and it glows in the presence of UV light. It has the symbol C20H12O5. As you can see, I'm going to prove this that it dissolves to get a green color. Here I have a graduated cylinder and I am going to put some water in it. Please bring the camera. bathroom and I am gonna add a very little amount of water to it. As you can see here, it's around 4 milliliters. Please zoom in to this point. Now you note the fluoresceins color is yellow and I have not added anything to this water. Actually, water doesn't react with copper to produce any green color. So that is salt. Let's try this out. Now I'm gonna put some fluorescein into this. A very little amount of fluorescein. Much more little. Because fluorescein can react in very small amounts. Less than a microgram. See here? Can you close up here? And this. I'm gonna put it. As you can see, the water has turned green. Can you see it? The water has turned pale green because of the action of fluorescein. Actually, I don't have a UV torch of myself, so I cannot make it glow right now. So that was just the proof that fluorescein produces green color. Now let's head back to the This chemical is used in, it does glow, but sometimes this chemical is used in a glow stick, but it does not react with chemical energy to produce anything. Sometimes this type of setup is created. I'm going to draw it with a pen on the paper to show you how to make a glow stick out of fluorescein. Actually, this what happens. Close up. This is the compartment where UV light are transported into this big compartment which has fluorescein. I'm going to write its formula C20H12O7.
Mr. Nikhilesh Duggal, after this, can we take a break?
Yes, of course. This UV radiation, actually UV lights excite fluorescein electrons to produce a glow. Actually, the reason of glowing is also said as chemical luminescence. It is formed by when the UV radiation reacts with the fluorescein, it excites its electrons, and when the electrons go on to react in the entire chamber, they produce a very bright glow. So that was the explanation of fluorescein glow stick.
Thank you, doctor. Sorry, Mr. Nikhilesh Duggal. Can we take a break now?
Yes, of course. And then I'm going to continue my montage further. Now here we are again to continue our montage. I left at fluorescein and we are now going to discuss about calcium bicarbonate. Calcium carbonate. Actually, calcium carbonate is a mineral we found in the form of marble. I have actually produced this white colored calcium carbonate by crushing these marble stones. As you can see, they contain calcium and carbonate.
Can you show us?
By separating them both, actually it's not possible because these both are actually already dug themselves into each other. As you can see, these shining particles are the particles of carbonate and the rest white is calcium. Actually, not only this much is carbonate. Carbonate is also grinded inside the stone. But by chemical means, we can break this down to calcium and other carbonates. But a radical like carbonate cannot exist free. It has to be combined with a little amount of molecules, as little as you want. And if we then break down the carbonate, it in small amounts will have calcium in it so that it could produce a stable reaction. But if that is not going to happen, the carbonate, all the radicals which are free produce a very, very explosive substance which in comes in contact with air or is moved, explodes very, very, very badly. So now calcium carbonate is done. Now we move on to ferric oxide. Ferric oxide actually exists two states. First as a mineral hematite and as a mineral magnetite. Both hematite and magnetite have the different formulas. See here, hematite is actually iron oxide having the formula Fe2O3, and magnetite is actually magnetized mineral of it. It has the symbol Fe3O4. The rust we find on the iron things are often ferric oxide or iron 3 oxide, meaning magnetite, because the rust, the atmosphere around us has so much air that it can automatically react with the iron to produce this. But actually that's a 1 in a million chance that the iron on corrosion produces hematite, because the oxygen around is very, very oxidizing, because oxygen is a great oxidizer. Oxidizing means being relevant to combustion. So it instantly oxidizes it to magnetite form, skipping the hematite form. Now we are here at silver chloride. Actually, I have here liquid silver chloride. But solid silver chloride is used in photochemistry because in the presence of bright, silver chloride decomposes. To show this reaction, I am writing it. Silver chloride plus, in the presence of light, actually let me cut it. Light produces silver plus 1 ions and chlorine 1.5 ions. Chlorine is released as 1.5 because when we want to print a template on it, the rest of the chlorine gathers to the template blackened area. So if we make chlorine chloride in the lab, silver chloride in the lab, and you put a torch on it with a template on it, with a dark colored template, the rest of the area without having the template decomposes. Actually the template should be of plastic, like this. I must show you. The template should be plain like this. When I was in the chemistry lab, I printed my name Nikhil on silver chloride by putting a torch.
Can we show?
Actually this time I don't have solid silver chloride, so unfortunately I cannot. So the silver chloride and silver bromide as well is used in photochromatic chemistry. And another thing, the silver chloride has a formula of AgCl, and silver chloride has this much uses only because it's not a very, very useful chemical compound. But actually, these are the times of modern photography and we use digital cameras. The old film cameras are really obsolete. So now moving on to the next chemical. This chemical is known as the corrosive sublimate, mercury chloride. Yep, this is mercury chloride. It's a very, very toxic chemical and it's harmful for the environment. Mercury chloride doesn't have much uses. It only has 1 or 2 uses. That it is used in bleaching industry. Actually, it is used as a poison actually as well. The people who just, my life is boring, I don't want to live, I hate my life, drink this chemical to kill themselves. Actually, that is a very broad explanation of mercury chloride. So let's skip on to the next chemical because it doesn't have any uses. But actually, I missed something. Mercury little uses, that's why I'm not showing it. But the most goodest metal is tin. I'm gonna show it later. The iron exists in +2 states and +3 states, meaning 1, 1, 1. These all are plus. And chlorine exists in minus state. So iron cannot be made simply by FeCl. It has to be created by 3 chlorine atoms to make it stable. So iron chloride is actually used in etching copper because it etches copper and is also produced copper chloride. Copper chloride, I'm going to show you again. This circuit board is actually made by putting iron chloride on copper surface to produce copper. So, the last property is tin is a very useful metal and it is used in canning some food items. Tin is actually really useful metal as it has a low melting point and is used to make alloys. The first alloy made by man, bronze. Bronze is actually consists of 50% copper and 50%